4. So a lot of times you're just looking at the relationship between the x and the y. So which one of these are independent and which is dependent? Remember, the dependent variable depends on something else happening. So the cost of a long-distance telephone call increases with the number of minutes of the call. So in this case, the independent, I'm going to just use I here, is equal to the number of minutes, right? Because the dependent is the cost, and it depends on how long you talk. For the water pressure, it increases at 0.44 psi, that's pounds per square inch, with each increase in 1 foot in depth below sea level. So your independent happens to be your measurement of the feet below sea level, and then your dependent is the water pressure, because it depends on how far below you are. Okay. So the next page has us kind of doing the same thing, but maybe looking at it a little bit differently. And it gives you some prompts on what to look at. So it came from a different section of the book. It says you can write a function, or rule for a function by analyzing the table of values. Look for a pattern relating the independent and dependent variables. So to write a function rule in example 1, you look at the x and you look at the f of x, it's just function notation. Ask yourself, what can I do to 1 to get 5? What can I do to 2 to get 6? And so on. If you add 4 to each x value, you get the f of x value. So you relate that f of x is equal to x plus 4, and you write the rule right here. Okay? Let's look at the relationship here. So again, if we were using that notation, because I still like to do this myself, but probably for reasons that I haven't even taught you yet. Because look what's happening. It's going up by 1, by 1, by 1. And if you haven't noticed, the relationship by looking at this change is giving us that coefficient of x. And so 1 times 1 plus 4 equals 5. So that's the coefficient of x is a 1, and that's what that relationship is telling us. Looking at the next one, this one's going up by 3 here, up by 3, and up by 3. This is going up by 8, but this is going up a lot more than 8, and so is that. So we're not going to get very far looking at the relationship between the change in each x value and the change in each y value. So what can I do to 3 to get 9, or 6 to get 36, or 9 to get 81? And so you're going to see sometimes that the patterns when you're looking at this are going to be so changing that you can't really relate it to each of those. So when you have that happen, again, you're looking at the relationship between x and f of x, and so it's squared. Y is equal to x squared. So 1 squared is 1, 3 squared is 9, 6 squared is 36, and 9 squared is 81. So sometimes you're just going to have to rely on looking at the pattern. So let's give a few more a try. Okay. So write a function rule for each table. So we can look at the relationship. We have x and we have f of x. So what am I doing to 1 to get negative 1? Well, I guess I'm kind of subtracting 2. And 2 to get 0, I could subtract 2, and 3 to get 1, I could subtract 2, and 4 to get 2, so that would be my rule. Okay, so what would I do? 2, 1 to get 2, or 2 to get 4, 3 to get 6, or 4 to get 8, and you can see that if you multiply by 2, so f of x is equal to 2x. Okay. Looking at the pattern, if you're looking at the change here, these are all plus 1. These are all plus 1. Here we have plus 1s. Here we have plus 2s, right? The change is plus 2. So this is where we talked about that being that coefficient. So 1 divided by 1 is 1, so that's the coefficient of x. 2 divided by 1 is 2, and that's the coefficient of x. So sometimes that's a helpful relationship, right? Plus 1. This looks like plus 1, so the coefficient of x would be 1. So 1 times 1, and then we'd have to add 2. 2 times 1, and then add 2. So x plus 2 becomes the function rule. So in this next section, it gives you an example, and then it gives you a value to substitute in. So you have the rule, and then you have to substitute it in to see how long it would actually be. So let's go ahead and come down to this page. So there's another example, and it was multiple choice, and it gives you the function rule. So we have 18n minus 245. In that one it says, suppose you borrow money from a relative to buy a lawnmower that costs $245. You charge $18 to mow a lawn. Write a rule to describe your profit, the P of n, as a function of the number of lawns mowed n. Which equation best describes the situation? So remember, when we're talking about profit, we have to first, take the amount you're charging per lawn, but you have to subtract your expenses or your cost of the mower. So that's where that minus 245 comes in. So in the quick check, it says, suppose you buy a word processing software package for $199, and then you charge $15 an hour for word processing. Write a rule to describe your profit as a function of the number of hours you work. So again, we're talking about profit. So $15 per hour, right? So we could do P of n is equal to $15 per hour minus the cost of that package will give us the profit. And then we have more rules and tables. And then down at the bottom where it says write a function rule for each situation, I kind of want to go through 10 through 18. I could put the answers for 4 through 9 as well, so you can test them and try them out. But looking at 10 through 18, there are just a few word problems. So it says the total cost TC of C ounces of cinnamon if each ounce costs 79 cents. So we would write the rule, okay, as whatever they've defined. TC is equal to your 79 cents per ounce, which will be C. Okay, because it gave us the C ounces. The total distance dn traveled after n hours at a constant speed of 45 miles per hour. So dn would be 45n. The height, f of h, of an object in feet when you know the height in inches. So we have to think about the relationship between feet in inches, and since 12 inches is equal to 1 foot, and we're going to convert to feet, and we have inches, that means we're going to be dividing it by 12 inches. So we would have f of h is equal to 1/12 of h, whatever that is in inches. A worker's earnings, E of n, and we're talking about all those different letters you can have for functions, after n hours when the worker's hourly wage is $6.37 per hour. So at a supermarket salad bar, the price of a salad depends on its weight. Salad costs 19 cents per ounce. What is the rule? So I always just go back to the f of x. 19 cents per ounce. How much would an 8-ounce salad cost? So we're basically wanting to find f of 8.19 times 8 equals $1.52. And then going back up, just so that you have these if you want to try them out. So you could check your work if you give them a try. For number 4, you should get a function rule that looks like this. For number 5, six, seven, 8,